Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, continuing the quadratic expression series, this time on factoring quadratics. This video is going to be a more basic version of factoring quadratics. Next one will be more advanced. Hopefully you get the gist of them. I think this one you'll catch on to pretty well. If this is your first time seeing it here, let's go ahead and break it down right now, get it started. Quadratic factorization rule number 1, the first one. In a factorable quadratic trinomial, x squared plus bx plus c, put a little 1 here. I'll talk about that in a second. The resulting form will be the quantity x plus p times the quantity x plus q, where b and c are the sum and the product of p and q respectively. What did we just say here? Let's get things started with, first of all, we're assuming that our quadratic is actually factorable. And we talked about greatest common factor before. They may exist here, but we're referring to a different kind now. We're trying to factor them to look like this, like when we distribute two binomials and they end up being this form. Now, what in particular I have here, I put a little makeshift 1, and the reason I put that is because this quadratic factorization rule number 1 is going to be based on a quadratic coefficient being a 1. After we've taken out any common factors, a positive 1. These ones are significantly easier, and they are more different than when it's not a positive 1. If it's not a positive 1, it's a lot harder. That's what you're going to see in the next video. This one, a positive 1. So, what's the next stuff here? We're going to make it factor and look like this. We're going to have the letters x here, literally, or whatever variable we have. Here you see x's, here you see y's, and j's, and x's again. So whatever your variables are will end up right here. P and q are actually going to be numbers. And p and q are two numbers that, look where it says here. B and c are the sum of p and q. B is the sum of p and q. And c is the product of p and q. That's what respectively means in order. It says b and c are the sum and the product. B is the sum, c is the product. So b, your linear term, are what p and q will add to, what they add to make. And then c is what p and q multiply to make. You might have seen, if you've seen this before, or if you've seen any form of this, you might have seen people draw like a diamond or like an X, thing right here. And what they do is it's a visual tool. It means nothing mathematically. It's just something someone once drew and said, hey, let's just make it mean something. And what they would put is, they put the c up here and the b down here, whatever the actual numbers are. Because remember, we're going to have actual numbers here, like 8 and 7. And these are the answers to what two numbers multiply to make c, and what two numbers add to make b. And that's all you're doing here. Once you figure them out, they are going to be the numbers that appear in your result. So the whole question is, and it says it up in the rule, but you might not know, it says sum and product and respectively and stuff. What we're finding out is this. What two numbers multiply to make c and add to make b? That's what's being asked right here. So keep in mind, c might be positive or negative, b might be positive or negative, b might even be 0. You have to keep that in mind as well. But that's the question that we're coming up with. And our values that we get in p and q are the result of the factorization as well. We'll double check it through distribution. There's more to why this is. I'm not really actually going to dive deep into that. I want you to feel out the process and get comfortable with it. So let's go ahead and get started here. Oh, by the way, I say to make c first, because I want to find out the products of c before I find out the sums of b. There are significantly less products for c than there are sums of b, and I'll show you what I mean. Now this is once again, it's a 1x squared. You're going to assume these are factorable, and if they're not, we'd say not factorable. But I'm going to go ahead and tell you, if I didn't mess up, these are factorable. 1x squared plus 8x plus 7. It is a 1x squared. That means we're coming in this form right here. We're going to find out c is like 7. You see that? 7 is c, 7 is c, and 8 is b. So if I drew out that diamond, again, I'm not a huge fan of this as far as like, I don't want you to live and die off the diamond. It's the question that matters. And if drawing the diamond helps you answer that question, that's fine. So my c is 7 and my b is 8. Okay. We're asking ourselves, what two numbers multiply to make 7 and add to make 8? Now here's what I'm going to do, and if you already know the answer, great, but here's what I'm going to do in general for most of these things. I'm going to look at my product of 7, and I'm going to list, this again is another visual, it doesn't really matter. I'm going to list all products, all factors of 7 that I can think of. For example, 1 times 7 gives me 7. Anything else give me 7? Not really, and that's part of what I said. I want to find factors of c before I find sums of b. What other numbers add to 8? 0 and 8, 1 and 7, I can't even do this, 2 and 6, 3 and 5, 4 and 4. Right? There are more sums of 8 than there are products of 7. Now, the product is positive and the sum is positive. So when we're looking for numbers that multiply to make 7, add to make 8, see, 7 could also be negative 1 times negative 7. But if I add negative 1 and negative 7, I get a negative number. So we know it's not going to be negatives, it's going to be positives. 1 plus 7 also happens to give us 8, so there's really only one answer to this thing. It's 1 and 7. 1 times 7 is 7, 1 plus 7 is 8. Does it matter if I put 1 and 7 here or 7 and 1 here? It doesn't matter at all. Now, what am I going to do with these two numbers? If these represent P and Q, if 1 is like P and 7 is like Q, then I'm going to write it in this form here. X squared plus 8x plus 7 is going to factor to become x plus 1 times x plus 7, right there. And that's actually the final answer. Now, if you want me to double check this, I'm going to erase the double checking after because of room. Actually, I can fit it right up here. Let's go ahead and distribute this and see if that works. X times x, x times 7, 1 times x, 1 times 7. That's that FOIL, binomial distribution. You learned that in two videos ago. So x times x is x squared, x times 7 is 7x, 1 times x is 1x, and 1 times 7 is 7. 7x plus 1x is 8x, and you get x squared plus 8x plus 7. So notice what happens here. The two last terms, 1 times 7, gives you that 7. That's c. That's why your two numbers right here multiply to make c. P times q is c. Now, why does p plus q give you b? Because because these are 1x's right here. So that means you're going to just multiply the x by that 7, which makes it 7x, and 1x, and they add to make the 8x. It's still a 7 and a 1 that add to make 8. So it's still going to be that. That's why it's important if this is a 1 that you're always allowed to do this. And that's why if it's not a 1, it makes it a lot more difficult. So anyway, just keep that in mind when we're doing those problems there. But that's the answer in blue, x plus 1 times x plus 7. All right, now I get to move faster for the next problems here. So let's go ahead to the second one. Y squared plus 13y plus 40. Now this time, when we break this thing down, keep in mind it's going to be a y something and a y something here and here, if that kind of makes sense. It's going to be y plus p, y plus q. You know what I mean? By the way, p and q can be negative. Will they be negative? Depends on the situation. I'll tell you what right now, because my product is positive, the two numbers that multiply to make 40, and my sum is positive, the two numbers that add to make 13, I'm going to guess it's going to be y plus something and y plus something, right? Multiplying two positives make a positive, adding two positives makes a positive. That makes sense. You can see later we'll deal with negatives and we'll get to that when we do. All right, let's find out factors of 40. Now this is where you can get, this has a hair of trial and error, but this is where you can just kind of make yourself a list or do as much mental work as you can. I knew the answer a long time ago looking at this, but let's look at factors of 40. There's 1 and 40, and by the way, it's easy to just divide by numbers. 40 divided by 1, 40 divided by 2, 2 and 20. 40 divided by 3, doesn't work. So 40 divided by 4 is 10, 40 divided by 5 is 8. And after that, it can't divide by 6 or 7, but it can divide by 8 and you get 5 again. So you're kind of back where you last were. So I think we found all our numbers here that multiply to make 40. At least our integers, right? When we talk about factorable, we're talking about the integer factors. Okay, here we go. So now they're going to be positive. So we say which one adds to make 13? 1 plus 40, that's 41. 2 plus 20 is 22. 4 plus 10 is 14. 5 plus 8 is 13. There it is. So 5 and 8 are your two numbers that would go in that diamond, 5 and 8. But what am I going to do with the diamond? I'm just going to place the numbers right here, 5 and 8. And that ends up being my answer for factorization. So once you find the two numbers, as long as it's a 1x squared or a 1y squared, find the two numbers that multiply to make this and add to make this. Those numbers go in your factorization. That's it. That's it. That's why I'm saying it's pretty basic form here. All right, third problem over here in purple. J squared minus 13j plus 42. Okay, so once again, if it's factorable, it's going to have this j form right here. Now, before I get started on the factors of 42, let's look at the idea that the product is positive once again, but this time your sum is negative. How is it possible to have a positive product and a negative sum? That's when you're looking at two negative numbers. A negative times a negative is a positive, but a negative plus a negative is a negative. So we're actually looking at a j minus here and a j minus here. Normally I'd save this for later, but I'm just getting you to anticipate what kind of answers you're going to be getting. So let's list out some factors of 42 this time. Now, by the way, before you knew the negative part, let's just write out positive factors for now. That's okay. We'll get to the negatives after. 42. We got 1 and 42, 2 and 21, I think 3 and 14. I believe so. I don't believe it divides by 4, 5, 6, 6 and 7, and that's where we stop there. Otherwise, we hit duplicates on the way back. All right. Now we know, once again, positive product, negative sum, both sets are negative. So find out the one that adds to make, I know they're negatives, but you still add negatives. Add the negatives to make negative 13, negative 43, negative 23, negative 17, negative 13. It's that one right there, negative 6 and negative 7. That's where we get j minus 6 and j minus 7. So once again, you can kind of see that idea that it's really just coming to fruition that way. We're done there. Now, this last problem here, I kind of have another problem like this on the next video. So just so you know, you're going to kind of hear this thing twice. That's okay. But the basic thing here is it doesn't look like a 1x squared this time, so it looks a little hectic. But and like I said, I really saved it for the other video, but oh well, I have another one. I guess I forgot to take it out. But what I'm going to do is these can all I can factor out a 4. I can factor a 4 out of these guys right here. And when I factor out a 4, I get x squared minus x minus 20. If you need common factor practice, look at the previous video. But what I did was I factored out a 4. And now within this quadratic, even though I factored out a 4, even though there are no more common factors, there still exists a possible quadratic factorization of this inner expression right here, this inner polynomial. Two numbers that multiply to make this and add to make this possibly. So that's what I'm going to look at right now. This 4 stays on the outside. And again, next video's the first problem in the next video is going to be like this common factor. And then we go. Factor the 4 out. We already did that. And how do we factor this inside part with this x and x? It's x plus something, something like that, right? So let's go and check it out. Remember now, this is a 1x squared. This is a negative 1x. That's important because going back to that diamond thing, we're asking ourselves what two numbers multiply to make negative 20 and add to make negative 1. That's what we're going for now. So I'm going to list out my factors of 20 here. And again, you can do this mentally. I do it mentally. I'm just showing you what it looks like. You can do this mentally. Trial and error. Just rummage through your factors of 20, see which ones add to negative 1. Now here though, I'm going to list my factors of 20. 1 and 20, 2 and 10, 4 and 5. Now here's the thing. 20 is not my product. It's negative 20. How do you get a negative product? One positive, one negative. Okay. How do you know which of your numbers is positive, which one's negative? Because the sum is negative. The sum is negative, the larger number is negative. Where are my larger numbers? They're these right guys here. We'll do 1 minus 20, 2 minus 10, and 4 minus 5. Which one gives us negative 1? Looks like it's 4 minus 5. That means a positive 4 and a negative 5 are your P and Q. So I'm going to write x plus 4 times x minus 5 right here. And that's the factorization. X plus 4x minus 5 is the factorization for this guy. You can distribute to double check. And the 4 is still on the outside. Remember, we factored this initial expression right here that did multiply by 4. I factored out the 4 first, and I'm always going to recommend that first. Find your greatest common factors. Again, next video is going to start with it. Find your greatest common factors first, and then you'll be taken care of there. All right, so those problems are pretty basic. And like I said, use scratch paper, write this stuff down if you want to. Or just keep trying numbers until they work. But the other thing that's really nice about this, remember, even though I picked factors of 20, I knew the product was negative, and I played with that afterward. I said negative product, negative sum. That means I'm going to do one positive, one negative. The larger number is negative. If the product was negative and the sum was positive, if it was a plus 1, then the smaller number is negative because you do large minus small. And then you get that. It would have been a positive 5 and a negative 4. So there it is. So again, a lot of mental stuff can come into play there. Some good practice. I want you to take care of that. All right, so that'll do it for this one, guys. This is Mr. Robinson. I'm signing off right there. Next video here is going to be on, it's more quadratic factorization, but it's when that 1 is not just a positive 1 and not necessarily just a common factor. It can get it to positive 1. You got to treat it a little more differently. It can be a little more difficult. Make sure you know how to do binomial distribution. Make sure you know how to do binomial distribution if you're going to watch the video. Take care.